nothingness. Then everything. This is the Big Bang. In today's video, I'm going to be telling you a bit about the origins. So, let's get into it. Yeah, I'm still spinning. What up? So, now what is the Big Bang? Now, the theory of it is that first like I said, there was absolutely nothing in the universe. Just imagine like an empty plane with nothing in it. This could either be nothingness, white, black, or who knows? Because we weren't there to see it. Now, in this time period, imagine a dot. Now, I want you to make that dot even smaller, and I want you to put the energy of all the suns in the universe into this one dot. This was the start of the Big Bang. Now, the Big Bang necessarily didn't go bang and then suddenly everything was here. That didn't necessarily stick. This isn't necessarily what happened when we have a look at physics and all the other maths to do with it. What mostly, from what we know, the actual speed of it probably wouldn't have even made a sound at all. It probably would have just happened. Now, in these couple of seconds when the universe just kind of expanded out of this tiny dot with all this mass energy, kind of like a black hole, I'll talk about that later on, everything around, space in its sense, or our galaxy, was 5.5 billion degrees Celsius. Think about how hot it is when it's 40 degrees. Now try to picture when it's 5.5 billion degrees. Now try to complain that 40 is too hot for you. Now, in this period of time where everything was heated around and photons are now bouncing around and trying to expand to create the universe, there was a sequence that was made that was allowed for the creation of matter. Now, in this circumstance, photons were made into both matter and antimatter. Now, this is kind of interesting because what is antimatter? So, now, the splitting of photons into matter, there had to be something else made out of it to the law of conservation of energy. Now, in this process, these photons get turned into both matter and antimatter. But in this sequence, it's kind of like magnets in a way. You see, matter and antimatter try to find each other out like magnets and try to destroy each other. But look around you. It's matter, right? Everything is in front of us. So how can that be when the universe and everything that we know scientifically should say otherwise? Well, this is when this is the totally not God coming into it, and yeah, we don't really know. Literally, nobody knows yet, because we can't be in the situation to find out why, and we can't simulate it because technically it's impossible to simulate the beginnings of a universe like it, since necessarily we don't even know what happened. But from the maths that have been done, we can say that when the creation of photons became matter and antimatter, there was about 1 billion bits of antimatter being created from these photons to 1,000,000,001 pieces of matter. And all of this happened in a billionth of a second. Now, we all know how long a second is. Now, turn that into a billionth of that time. And in this time period, the universe cooled down enough to stop this process, and we had enough matter to create everything in the universe. That's right, in that billionth of a second, everything we know had its building blocks. Now, it wasn't until 380,000 years later until something else big happened. What happened, universe? First, you take a couple of milliseconds to make everything we know, and then you need 380,000 years to complete like the very start of everything else, the creation of atoms. So yeah, at this moment in time, matter is like the universe is opaque, because in this situation, at this point in time, we have neutrons, electrons, and protons, but not atoms. So these atoms all around the place are scattering the photons, which is the light, all around the universe. And it's scattering it so much that if we were there in that situation, we would see nothing until they started making atoms. Now, in this situation, they made two different types of atoms, the most easiest to make in the periodic table: hydrogen and helium. Now, at this point in time, because it's so easy to create these two, but one is more easier to create in this situation. So when we think about all the atoms being created in the universe in this point in time, about 92% were hydrogen, and the other 8% were helium. We don't just have hydrogen and helium. There's like over 100 elements in the periodic table. Where did all those come from? Well, they came from the smashing together of those elements in high speeds, connecting them together, making more elements. Isn't that neat? Now, how did we come up with the universe? Well, now, this theory was there, and it was one of the theories that were a concept in science, but there wasn't too much proof at this time, at least early on. There could also be a case of God making it. So the actual proof of it, so this proof was discovered by Arno and Robert by accident. It was the cosmic microwave background radiation. Now, let's get into the microwave effect. Oh, Dad? Is that you? So, now, how did they find this? Actually, they found it out by accident, and it wasn't proven real until 20 years later, and they won a Nobel Prize for it. Just, like, imagine looking into a telescope and and finding Jesus, but you confused it for a smudge in the lens. A smudge in the lens! Now, these guys were making a satellite. They were making a satellite dish at this point, and they were trying to get a pure silent sound out of it. But they always thought it was some kind of hum in the back. They always heard this hum in the background, and they thought it was from some chicken droppings in the dish that was making these hummings. Until 20 years later, when we found out it was actually like the leftover parts of the universe, because once those atoms were created back, when the hydrogen and the helium were all being created, they left photons behind, and these photons can still be tracked. Hell, if you turn on your TV or listen to your radio right now and it has no signals in it, guess what? You're seeing the universe. Well, don't mind me, it's only 1% of the universe, but still, that's more tangible proof than technically we can ever get without a time machine or a way of recreating the Big Bang. And these guys found it by accident. And so yeah, that's the Big Bang. It's so fascinating thinking of it, just this ball of energy and then bam into everything. And while these credits roll, I'm going to be telling you about something I told you I was going to come back to beforehand. And it's another theory that I kind of find interesting, that I thought about when I was doing research on this topic. You see, black holes, one of the ways they can be created is, for example, if you have a room completely full to the brim, nothing else can fit in it, and then you try to fit one more piece of something in there, that friction and everything else creates too much mass in that room, and it theoretically can make a black hole, which is kind of similar if you think about it to the beginning of the universe. So there's this theory I heard, but I haven't done too much research into it. But anyway, before I talk about that theory, I might as well talk about what I think about it. In this case, you could say that the Big Bang is kind of like a reverse black hole. While a black hole sucks in everything, it's kind of like an expansion of everything. Which leads me to a theory that I heard when I was talking to somebody about it, which is like black holes, they take all the information from everything when they're sucking it in, and then eventually when there's nothing left but all that information and energy packed together into a little burst, the universe restarts. It restarts all new, like a fresh restart on a computer or some piece of technology. Isn't that fascinating? Anyway, hope you enjoyed the video, and I'll see you next time. Boy, oh fuck.